Welcome to types of fuel. I think we're on 6.4. APES. Okay, so fuel, again, we produce heat, we produce power, and that power could be electricity or transportation. So a big idea in this energy unit is efficiency and quality. So efficiency is how well do we put the energy out, and how much energy do we have to put in to get the energy back out. So this efficiency thing is a big deal. It also needs to be affordable, which is always a problem. So ideally we would like it to be affordable, efficient, and high quality. And that is really, really hard to get. So not all energy sources can meet these three standards, and different energy sources meet them at varying degrees of success. There's no one magical ideal source of energy yet, but there are ideal sources for each region. So we're going to look at that. Okay, so obviously the very first energy source would be burning wood, firewood, charcoal, and it's easy. It's easy to go out, chop down a tree, set it on fire, cook your food, keep your house warm. Basic needs are met. A lot of times when we hear the word charcoal, we think coal, and that is not what charcoal is. It's actually this process to burn down wood into a small charred piece that you can relight. So when you're buying charcoal at the store and you're grilling your burgers on a charcoal grill, it's not coal. It's not that fossil fuel. It's actually from tree lumber. Sometimes that's a misconception. And this is a video you can watch if you want. It's kind of like a hillbilly teaching you how to make charcoal. All right. Another basic way to get energy is from peat. So peat is partially decayed plant matter, and you can burn it for fuel. If you let peat go for a long time and add heat and pressure and high temperatures, you will get coal. So peat is actually the beginning stage of coal, but peat is something that is readily available. It's called peat moss, and it is burnable. And this is a good video here that kind of talks about what's going on in a swamp and how peat bogs are kind of structured. But a very interesting side story is these peat fires. So this is a kind of a case study for apes. So peat is highly flammable, and it burns underground. You can see it right here. It's burning underground and it smolders. Smolder. Like Rapunzel, Twisted, Tangled, whatever that movie was. Okay, anyways. So forest fires, they just burned short term, a couple weeks, maybe months, and they burn the surface and you can see the flames. Peat fires burn for up to years underground, and the surface just keeps smoldering and smoldering, so it releases way more carbon than a surface forest fire. So what happens is the peat is burning underneath, and it spreads, and then it'll start popping up where there's cracks or fissures in the earth, and sometimes it can smolder underground for a long time and then boom, come up on the surface and make these giant peat fires on the surface. And a lot of times people who live there don't know when it's going to pop up, and it's kind of scary and very surprising that your whole place is on fire all of a sudden. Okay, coal. You need to know this process. Look at this beautiful graphic. Put it in your very important notebook. Put it in that AP Comp book. You need this process. So again, when coal is created, it begins as peat, which is not coal. Again, it's a partially decayed plant matter in the swamps. It doesn't have a lot of heat content. So if you were to burn this, it's not a great thing to burn. I mean, you can, obviously, but it's not high quality. It's not giving you a lot of heat. Over time, with heat and pressure, you get the first lowest grade kind of coal, which is called lignite or brown coal. So it doesn't have a lot of sulfur in it, which is a good thing, but it's not around. It's not very readily available. But if we let it go and do more heat, more time, and more pressure, then you get bituminous coal, soft coal. This is one we use because it has a high heat content, it's readily available, but the problem is there's a lot of sulfur in it. Why is there sulfur in it? Sulfur is naturally occurring in soil and in rocks. And so as this forms, we're compressing the sulfur element into this lump of coal. And so when you burn this, you're going to give off SO2, which, just for future reference, will get into the atmosphere and mix with water, and you will get sulfuric acid, which will become acid rain. Okay, more time, more heat, more pressure, and you get anthracite, the best of all the coal. Highly desirable, has high heat, low sulfur, but it's not around. It's not as available. So it's very, plus you gotta wait around for a long time. So this is kind of the stages of coal. So notice over here we have more moisture on the lesser side of things, and we have more heat and more carbon on the longer side of things. And that's all about time. All right. So sulfur, again, can be this big problem. And don't think because these both have low sulfur that there's no sulfur. So these are still putting that sulfur into the atmosphere when we burn it. And that's going to be a big deal when we get to air pollution. So hang on to that little piece of information in your brain. Remember, everything's connected. Okay. So another one is natural gas. Natural gas is mostly methane. If you don't know your chemistry, methane is CH4. And so this is the cleaner fossil fuel. What happens is when you burn it, which means you add oxygen, that's what combustion is, adding it with oxygen. This breaks apart into two things, water and carbon dioxide. Well, those things are naturally occurring and those things are naturally in the atmosphere anyway. And we're not putting sulfur or other particulates or ash or soot or anything into the air when we burn natural gas. So of all the fossil fuels, this is the cleaner choice, but it's still methane, and that could be a temporary greenhouse gas, which is pretty large. Okay, so methane is formed over time. It has the decayed remains of plants and animals, the sand, the silt, the rock. And so methane will be in this like kind of gap. So we'll have, maybe I should make this a different color. All right, so we've got the same story that created the oil. So here's your oil, but then there's this capstone rock usually. I don't have a brown color. Sad. Okay, let's just pretend this is it. So then you've got this rock that's over the oil, and then a lot of times there's this gap between the rock and the oil, and that's where the gas accumulates. So the natural gas will be all up in here between where the oil is and the top of the rock. So remember, it's going to go by density. So the solid, the liquid, and the gas. So when they come to drill in, they'll tap through this rock and they can let this gas leak out. And then they know where there's gas. If they go deeper, there's going to be oil. Okay, look at these numbers. It takes millions of years for this to happen. So that's why it's non-renewable. Okay, crude oil. So oil is, when it first comes out of the ground, it's not what we think of as oil. So it has to have some chemistry done to it. Okay, we also have that tar sand oil. We watched a video before with that tar sand in Canada. So that particular type of oil has clay, sand, water, and something called bitumen, and that has to get extra processed to make it a usable kind of petroleum oil. All right, so petroleum oil is used to make lots of things in your life. It may be surprising that it's in so many things. Plastics being the big one, you know how I feel about plastics, but that comes from oil. We have to drill it out. Same oil that turns into gasoline for our cars goes into plastics. P.S. Glitter is plastics, and I hate glitter. Okay, paints. So sometimes we have these oil-based paints. So what do you think that oil is? Yeah, fuels. So gas and diesel, propane, butane, all those things are from oils. Fertilizers have some fossil fuel oil in them. So then we have other stuff. There's medicines that have it. The toothbrush, toiletries, our sports equipment, electronics, candles have oil, sunglasses, clothing. Oh my gosh, all this stuff has fossil fuels in it. What the heck? Alrighty. So how do we get the different fuels from all this crude oil? So again, when it first comes out of the ground, it's crude oil, and then we heat it. And when you heat something, it will separate out by its density. And so the lighter stuff will go toward the top, and the heavier stuff will go towards the bottom. And each little separation has a use. So you can see on this really kind of cool, useful chart here. So the lighter stuff, the gases, are the propanes, the butanes, the hydrocarbons. So that's natural gas. This is propane for your grills when you get that little tank of stuff and you light your grill like for that. Some cars run on that. Then the lighter naphtha is regular gasoline. And then we get to jet fuel. So we have kerosene and diesel fuel and fuel oil for heating our houses. So there's different mixtures and different combinations of gas. You can see gases all the way down because we blend our fuels at different times of the year. So, and then we get into oil, and then we get like the lubricating kinds of oils. So there's something for all of the various densities of the gas. This is fuel oil to heat our homes. So just so you know. All right. And then we can actually use parts of it to turn into concrete and asphalt. So I guess the good thing is we use all of it, but the bad thing is we're mining it out of the ground and there's only so much left. But at least for chemistry, we've found a use for all of the different densities of oil. Okay, there's this concept called cogeneration. You need to know this definition, which is right here. So when you generate electricity, you're sometimes creating another kind of energy, like maybe heat. So to do these processes, you lose and give off energy in different forms. Sometimes it's sound, sometimes it's heat. So cogeneration is this idea that why don't we take that heat and use it for something else and make a use for it instead of just letting it waste and go up into the atmosphere and heat the planet. So let's read this together. So the generation of electricity and other energy jointly, so we're creating those together, and especially the utilization of the steam left over from electricity generation to produce heat. So what you're doing, let's look at our graphic. So with a coal-fired power plant, half of the energy is wasted. Cogeneration reduces the primary energy demand by 36%. So if we take this coal-fired energy and that becomes electricity, and we have this boiler heating oil and that produces heat, we're kind of losing it. But if we do it together, we can send the electricity to our home and the heat to our furnace to heat our home. So we've got the lights and we've got the heat. So this idea to do it together actually makes things more efficient. So cogeneration is a more efficient way to use our energy generation when we make our energy and to make sure that we don't lose a lot of it and to make it more efficient. It's just an idea. You don't have to go crazy with it on the test. Just know it exists and the basic definition. All right, we did it. So this was not too long of a lecture. Please read your chapter. There is a good explanation of cogeneration in your book, so make sure you do that. And I will catch you in class.